Welcome to Spring LIB.
So here in this problem, it is given that the main radius of a square threaded worm gear is 2 inch, and the lead of the screw thread is 0.5 inch, and there is a constant couple is acting on the larger gear whose magnitude is 9.6 kips inch, and the direction of couple is in the clockwise direction. This is the direction of couple, and we are given that the coefficient of static friction between the two gears, it is 0.12, and we have to determine the couple that must be applied to the shaft AB, this shaft, in order to rotate the larger gear counterclockwise. So first of all, we'll be making the free body diagram of the larger gear. So this is the free body diagram. Now we have to find the value of W. So for that, we'll be using one equilibrium condition, that sigma moment about sigma MC equals to 0. That means moments about point C, the center, it is 0. So I'll be taking the moment of the forces in this direction to be positive, and in this direction I'll be taking it to be negative. So we can write that W into R C minus C. C here is the couple whose magnitude is 9.6 kilopound inch. So it will be equals to 0. Now we can plug the value here. So W into R here is RC here is 16 inch minus the value of C is 9.6 kilopound inch, and it will be equals to 0. From here W comes out to be as 0.6 kilopound. So if we convert this thing into pounds, we'll get 600 pound. Now next we'll be making analysis of the block and incline of the worm gear. So for that we'll be making the free body diagram of this screw thread. So here you can see the free body diagram. Now before proceeding further, we have to calculate the angle theta, that is the lead angle, and phi s, that is the angle of friction. So we know that the angle of friction phi s, it is given by tangent inverse mu, and mu it is 0.12. So from here the value of phi s come out to be as 6.84 degree. Now next we will be calculating theta. For that we should know this dimension, and we know that L is 0.5, it is given in the problem, and pi times d. So we are given the radius to be as 2 inch, so diameter will be 4 inch. So this dimension, the horizontal dimension, would be 4 pi inch. So theta would be equals to tangent inverse 0.5 divided by 4 pi. So from here theta comes out to be as 2.28 degree. So we have calculated theta and phi s both. Now here we observe that there are three forces acting on this block. So we can do one thing. We can make a force triangle to make things easier. So basically we have to calculate the couple, that is torque. So we know that the formula for torque is T is equals to Q into R. So for that we have to calculate the value of Q, and we can use this triangle to find out the value of Q. So the value of Q from this triangle would be equals to W times tangent of theta plus phi s. So it will be equals to W, we know it is 600 pounds, so 600 times tangent of theta plus phi s. So theta, and this is theta, this is phi s. So if we add both the number, we'll get 9.12 degree. So from here the value of Q comes out to be as 96.32 lb. So we can plug the value here. Q is 96.32 lb times R. R here is 2 inch. So torque come out to be as 192 lb dot inch. So this is the final answer for the given problem. So I hope you got the problem. Thank you.